everybody, and welcome to MiceTech Talk with the technical information scientists of the Jackson Laboratory. My name is Dr. Janine, and I am coming to you from my home in Sacramento, California.
And my name is Sarah, and I'm coming to you from a nice spring day in Maine. Can you hear me all right, Janine?
Yep, I sure can. And you're Dr. Sarah, by the way.
Dr. Sarah. I am.
Our job in technical information scientists, or TIS, is to serve the research community by answering all of your mouse-related research questions. You might recognize us from our formal webinars on Thursdays, and actually I think we have one today even. Or you might even have called us late on a Friday evening asking for last-minute help before the weekend.
And right now we're doing something that we're calling our MiceTech Talk. It's a weekly 15-minute kind of podcast-style webinar. We're trying to ask some of the frequently asked questions that we get on our normal calls. We wanted to develop the show. It's part of our desire to build community among all of our fellow scientists. So we wanted to help reach out to you in this time that we are all going through.
So hopefully you've gotten your coffee or your beverage of choice, and you've put your feet up because it's time for MiceTech Talk. So today, let's talk breeding.
Yes, breeding. We talk about breeding all the time, and it's a big topic. So we're going to do a couple things. First, we're going to kind of get your impression of what you want to talk about. So what areas of breeding are you most concerned with? So to do that, we're going to use what we call poll questions. The first poll question is going to be kind of a fun one, just to get you set up for how to do a poll question.
Yeah.
You wanna?
So, yep, our fun question today is, what type of scientist things have you done while working from home? A, read a paper, wrote a grant, or planned an experiment. Very sciencey. B, attended some sort of virtual lab meeting or virtual scientific conference, also very sciencey. Aliquoted something and referred to it as aliquoting to some non-scientists in your household. I've done that.
Absolutely have done that.
D, Googled how to make hand sanitizer and then checked for peer-reviewed publications on the effectiveness of hand sanitizer. And then E, made Punnett squares for flower breeding and Animal Crossing.
Which I believe you have.
I've done all of those things. I've done all of those things except for the really sciencey things. So I'm going to let that go for a few more seconds. I'm going to close the poll now, and
we'll see what people say.
See the poll results. So a lot of you have been actually very sciencey and have gone to virtual lab meetings, done papers, grants. The few of you have also used aliquoting. I like that. I did that with my chicken the other day. So I had like fresh chicken, I chopped it up, and I put like frozen aliquots in the freezer. So none of you are playing Animal Crossing. And the reason why I put that one on there is because there is actually flower breeding that's happening in this game called Animal Crossing, if you are playing it. And it does go into Mendelian genetics to some degree. So I thought that would be a nice transition to our next poll question, which is the real one. So now that I know you guys know how to do that, let me open up the second one, which is our real poll question. Which breeding related questions do you have? And select all that apply. Maybe it's A, you want to know which breeding scheme to use. B, your mice aren't breeding and what should you do? C, you may just want to know how the strain breeds, and go ahead and use that polling section there. We're going to let the polls run. Depending on how you guys vote, we've prepared all three topics. Also, just wanted to make you guys aware, and I see some of you have already been using the Q&A part. You can actually put questions into your Q&A section. The polling part is separate, but you can actually put questions and answers into the, we'll tell you the answers, but you can put your questions into the Q&A part, and we'll try and answer those live. So, all right, I'm going to close the poll out. Enough talking about polls, poll results. We're pretty evenly spread. It looks like we have just slightly more people who want to know what breeding scheme to use, and then I saw a few people in the Q&A also.
Yeah, so that's a pretty even spread.
Split. Yeah. Okay, so Sarah, why don't we start with the first one, which is how do you figure out what kind of breeding scheme to use?
I do just want to say, I know we only have 15 minutes, so this poll is really great because it lets us know that you're interested in these other topics. So if we don't get to the other two topics, it's great for us to have for future MiceTech Talks. All right, so I am going to show you where you can find some information on breeding. And we're going to start with a couple different strains we're going to look at. Okay, so hopefully you are all seeing my screen right now. And I'm going to start actually by going a little bit of a step back. So if you haven't worked on our website before, if you have, this all may be very familiar, but I just want to show you kind of one way to get to our search function. So this is our main website, www.jax.org. And under this tab, Jack's Mice and Services, under Find and Order Mice, you want to click on this search for mice. This is the best way to search for mice in our catalog. And so you can search by stock number, keyword, and you can use filters. I've already pulled up a couple because I want to show you where on a strain data sheet to find information about breeding. And I want to, and what sort of information might be appropriate for you. So I'm going to start with I picked a couple of just Cree strains. I worked with Cree a lot, so they're kind of top of my mind. So this is our strain data sheet, and we have a lot of information here, and I wish I could go through all of it, but I can't. So the tab across the top that says technical support, we have both breeding considerations and mating system. I usually just click on the tab because it brings you to the whole area. And this is a really great place for finding information like genotyping protocols, some appearance information, and then we have both breeding considerations and mating system. This is an example of a Cree that we described as being bred as Hemizygous. And under our mating system, we say non-carrier by hemizygous, hemizygous by non-carrier. If you're not familiar with why we write it twice, this can be kind of confusing. The reason why is that we always put the female of the breeding pair first and the male second. So what we're saying is that you can breed either by a non-carrier female by hemizygous male or a hemizygous female by non-carrier male. So sometimes we put that twice. So that's something that, and what's important here is to understand that this is actually how we're breeding it in our facility. And sometimes the breeding considerations may be a little different from how we're breeding in our facility. It may be that you need to breed them in a certain way for your experimental design. You may need them to be hemizygous or homozygous. We may breed them in a way that is not designed for experimental design. It's more designed for maintaining a colony. One thing to note, because we get this question a lot, is, why do we breed them as hemizygous? In this particular case, this is a strain. It's a transgenic strain, and transgenic strains often are unknown integration sites. So a transgene integrates randomly into the genome, and for a lot of our transgenic strains, we don't know where that integration site is. And where you can find that is under the tab genetics, and I just scrolled up, and you might have to click on the little plus sign. And when you do that, you can see right here under chromosome, this UN indicates it's an unknown integration site. If we do know where the integration site is, we'll usually indicate it here. So this is an example of one Cree strain that we have.
Hey, Dr. Sarah, do you have one that's like a home-by-home mating by chance?
Yeah. Let me move on. And so this is another Cree strain. And again, I just picked kind of random ones, so these aren't designed to discuss them in any detail. But again, you go to technical support, and here's one where we do have a description here that you can either breed hemizygous to wild-type siblings, to Black 6J, or to generate homozygous colonies. And under the mating system, you'll see homozygous by homozygous. So this is an example of one where we do breed home by home. But you can breed them in a way that better suits your research needs. One thing to know is that for Cree strains in particular, you don't need them to be homozygous for the Cree to be functionally active. So we breed them as home by home for homozygous by homozygous for efficiency, but you don't need to necessarily breed them the same way we breed them if it works better for your experimental design.
I think this is pretty cool to note, though, because if you are trying to improve your breeding efficiencies, you can know that some strains can function, at least from a breeding and viability standpoint, as homozygous breeders. So functionally, for the the function of the Cree, that might not be necessary, but this is helpful to know in case that is beneficial to your breeding ratios.
And there are times when you may find that having the Cree be homozygous, especially if you're working with multiple alleles, can be beneficial for you in the long run. And again, it really comes down to what your goals are and what you're looking to do. All right, I have one more example I'd like to show, and then maybe we can look to see if we have any questions in the Q&A. This is another example of a Cree strain. This is a Cmv Cree. And the reason I picked this one is that this particular transgene, we do know the integration site. It's X-linked. So when you're breeding the strain, what this means is that you can breed them as homozygous for females. The males are hemizygous, and because it's X-linked, when you breed the male, only the female offspring will have the transgene because it's an X-linked X-linked transgene. And so again, this is our mating system. We always put the female first, so homozygous females by hemizygous males. So this is where reading the breeding consideration can be really helpful, because if you only looked at the mating system, you might not really get that context that's really necessary for understanding how to use these mice. So do we have any, I don't know if we got any specific questions on kind of mating schemes or how to determine mating schemes, or any thoughts you had, Janine, because I don't want to tie up all the time.
I don't see any there, but I thought maybe we could, since we had pretty even distribution, we can go on to the second consideration, which was, so Sarah pretty nicely summarized where you can find kind of maintenance schemes. And again, that's distinguished from generating more complex models. We actually have like huge webinars on generating complex models. So we can help direct you to those at another time. But maybe let's move on to what happens if they're not breeding. So what are some common concerns about breeding, and what can you do to try and fix them?
The most common concern is my mice aren't breeding. That's almost always the calls that we get, the questions we get. So we do have a kind of a troubleshooting guide or a fact page on breeding that we keep on this is again on the tabs across the top. You see this Jack's Mice and Services. Under this down, if you go all the way down to customer support, we have a technical support page, which has a lot of great information. And this particular page is one that is all about breeding. So we have a lot of different facts about breeding, information, why my mice won't breed, planning colonies. We even have can this transgene breed as a homozygous, which we just discussed. And we have this section here, tips for poor breeders, that we'll spend a couple minutes maybe going through. Jeannie, do you want to start with some of the considerations?
Yeah, so they're kind of listed here, but I would say like the biggest summary that you can take away from this tips for poor breeders is mice really like things calm. They like things quiet. Mm-hmm. They like things kind of dark.
They like things consistent too.
Yeah. I've talked to our veterinarians, and they said mice really don't like novel things. So anything you can do to make it kind of calm and quiet, minimizing noise, minimizing handling. I think people get really anxious, and they're like, my mice aren't breeding. And they go and check on them, and they like pull out the cage, and they like turn on the lights and do all these things. Mm-hmm. So I think the less you can do that jostles the cage, and the more you can do kind of like on the outside looking in, just to make sure that their welfare is intact. Providing nesting materials is another thing. So you can provide things like nestlets. Some people also like to use little shacks and domes. There are some domes that are actually clear, but are kind of like a red tint. And the mice actually see that as darkness. So you can see in through the kind of clear plastic redness, but they can't tell that there's light coming in from the outside. So they like the lights out. And I think, Sarah, didn't you have an anecdote about darkness?
Oh, yeah. So this actually occurred. This was a number of years ago when I was working in the mouse room still. And we had, and this is actually also something to bring up, is to talk to your fellow, like the people working in your room, because what happened was my mice weren't breeding. They were breeding just very poorly. And from just chatting with other people who had mice in the same room, I learned that actually all of our mice were breeding very poorly. It wasn't just my mice. It was kind of a whole room. What we found out had happened was the timer that governed our lights wasn't working. And so the lights were actually being left on all night. And that just the effect of constant light on our mice was that they just stopped breeding poorly. And the only way we found out was because someone happened to go in right at the time when the lights were supposed to go out, and the lights didn't go out. And that's when we realized. And it's one of those things. So it's kind of if you're ever having trouble breeding, see if it's something that everyone's experiencing. If everyone's experiencing, then that definitely would lead me to think that you might want to check environmental conditions. Temperature, humidity, light, sound are all great things. Sometimes some strains are just challenging, though. Some strains are great breeders, and so when they stop breeding, well, something's kind of changed. And some strains, though, are challenging breeders. So maybe we can kind of go into. We got just a few minutes. Do we want to try a quick jump?
Yeah.
Well.
There's also diet on there too. Diet
Yeah.
is something that I wanted to mention because there are some strains that do better with a 4% diet. There are some strains that do better with a 6% fat diet, and there are some that do better on like a breeder chow. So I know for sure like Balb C and Balb CJ, CBYJ and CJ, both of those Balb substrains actually do better on an 11% fat diet, whereas most of our strains are on a 6% fat diet. And I know wild strains actually do better on a 4% fat diet.
And one thing about the diet too, something that I've had a little bit of mixed success with, but it's something that I know some people have had great success with is what they call love mash. It's a breeder diet. And there is, I know somewhere we have a recipe, but you can also buy it from kind of a local commercial company. And it's a diet that's designed more for helping breeders. Haven't had great success myself, but I know some people who swear by it. So it's one of those things you can always try.
Yeah, it's probably strain specific too, because I think like we might not think of mice as being like inherently that different because they're laboratory mice, but they're actually pretty different, and there's some strains that actually do better on certain diets than others. So I think the important thing is you've got to know your strain, and then also talk to other people who might have been using that strain to see if there's anything in particular that they've, secrets.
And for some of our strains, we do have some information about whether they're kind of good breeders or challenging. So this is an example of an FEB, which if you've worked with them, everyone I talk to always talks about how they breed really well. And we even have on our breeding considerations that this is an exceptional breeder. They tend to be pretty prolific and have fairly large litter sizes. But you have an experience with one that is the opposite of FEB, which is the NZB.
Right. So I've been helping someone with this strain for, I think, like a year and a half. They contacted me originally just to get mice, and their particular facility needed to rederive the strain, and that was just a regulation from their facility. So they had initially asked me if they could get embryos, because that would make it so that they wouldn't have to, do the rederivation themselves. They would have just gotten the genetic material and then gotten pseudopregnant females and had them born in their facility. So this particular strain is one we didn't offer as a normal, I talked to our reproductive scientist group, and they said they get really poor recovery of these embryos, and it's just a strain specific.
And yeah, we have it's challenging.
Yeah, we use the same protocol for everything, and this is one that it doesn't do well. We would normally give people 60 embryos in 2 different straws, so like 30 embryos and 30 embryos, so you can do 2 separate techniques. But this one, they recommended like 200 embryos. So just to give you an idea of scale of like how terrible of a breeder these are. I also talked to our production manager who runs this strain, and they also run into a lot of difficulties. So there's a lot of different things that they've tried. They've been giving them a lot of different types of enrichment, like little alpha twists for them to kind of reduce stress. But it's not something that they've been really successful at.
All right, I'm going to stop sharing because I think we're probably just about towards the end, but maybe we can see if we have any.
I think we're about out of time. So as you guys realize, we can't talk about everything breeding, but we probably could talk about it for like hours and hours. I know I have. So if you guys want to continue this type of conversation, our team is in control of what things we talk about. So if you guys want to talk about breeding all day long, send it to us in the survey that's going to pop up at the end of this session, and we'll try and work it into the schedule.
And I also want to say that if you also have any very specific questions, so 15 minutes, we can only go into real generals, but if you have specific questions, definitely contact our MiceTech team or our technical information scientist team, micetech@jax.org, and it's on you'll get it in the email when you get the link. So.
Right. That's all the time we have for today. I hope you guys tune again next week for MiceTech Talk when we talk Let's Talk Controls.
All right, cool.
Dr. Janine saying goodbye. We miss you. And stay
Dr. Adrian saying goodbye.
Stay healthy, stay safe, and stay excited about research. Bye, guys.
Bye, guys.